Let's do question 6. We're having a graph of function f of x is equals to log of base 4x is drawn below, and it has a point of B which has the x value being k and the y value being 2. So this is the diagram here. 6.1, we are asked to determine the value of k. So we're having our function of f of x being equals to log of base 4x, right? And the b point is k and 2, right? So we can substitute the value of 2 here to find the value of k. So we're gonna say 2 is equals to log of base 4x, right? And this 4 here, since it's our base, is going to be the 4 to the power of 2 is equals to x. So x is equals to 16. So therefore, our k value is equals to 16, right? So that's how we solve this problem here. So now 6.2 says that we should determine the values of x for which f of x lies between minus 1 and 2, right? Remember, in the previous question we were calculating the value of k, which tells us that k is equals to 16 here, therefore the y value is equals to 2, right? So if you look at this restriction here, it says that the value of y lies between 2 and minus 1, right? So meaning that we want a value of x now, because we already know the value of x is equals to 16 at y is equals to 2, right? So now let's find the value of x at y is equals to minus 1, right? This minus 1 here. So what we're going to do is we're going to use our equation. So we have our equation of f of x being equals to log base 4x, right? And we already know the value of y being equals to minus 1, right? So we're just going to put minus 1 is equals to log of base 4x, and then 4 to the power of minus 1 is equals to x. So this is our value of x, which is equals to 1 over 4. So now we know that x is actually equals to 1 over 4. So that's how we're going to write. So we can write our restriction like this, which means when y is equals to 2, which is this value here, x is equals to 16. So you're just going to write 16. And then when y is equals to minus 1, which is this minus 1 here, x is equals to 1 over 4. So you're just going to write 1 over 4. So this is the answer that we're looking for here. Okay, so we are done with this one here. Now 6.3 says that we should write down the inverse of f in the form y is equals to. So we have our equation of f being equals to log base 4x, right, which you can write y is equals to log of base 4x, and then you swap the x and the y. So here will be the x equals to log of base 4y, and then we can therefore say y is equals to, this is the base, so just going to write the base, and the power is this x here, just going to write x. So this is the inverse, 4 to the power of x. So let me write this x properly, to the power of x. So that is the inverse of the graph. So now in 6.4 says that for which values of x will x multiplied by the inverse give us a solution of less than 0. So what this means is this. So this is the graph of f of x, right? And if we were to draw the inverse of this function here, we will have the line of y is equals to x, line of y is equals to x. So this y is equals to x is actually represented here. If I want to show you, so it's actually represented by this x here. This x, it's actually an x value. It's like having y is equals to x. So instead of writing y here, they wrote x, right? So this x is actually stands for this function of y is equals to x, right? Cool. So we're having the function of y is equals to x, and then the inverse will be somewhere here. So it will be somewhere here, like that, right? So this would be the inverse of f, right? So what they are saying is, if you have your equation of y is equals to x, right, multiply by the inverse of f of x, right? When you multiply both, they give you a solution that is less than 0. So let me just write x multiplied by the inverse of x, f of x, and then it's less than 0. So what this means is we are looking for a solution of y that is negative, right? So when you multiply the equation, the y value of y is equals to x, and the inverse, this inverse here, when you multiply the y values, you must get a solution that is negative. So if we check, just gonna indicate here, the y values here are positive, 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 positive throughout. They're positive here, positive here, positive here, positive here, positive here, right? And then here the y values are negative, 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 negative. Even though we're not really interested in the graph of f of x, but if we look, because we're interested in the straight line, so the y values here are positive. Okay, I made a mistake here. I said y values are negative. Let me just indicate, just for clarity purposes, the y values here are positive, right? Cool. So just by looking at this straight line, the y values are positive here. They are positive, 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 positive. But here the y values are negative, right? So we want to look at a situation where when we multiply the y value of this straight line, y is equals to x, and the y value of the inverse, they must give us a solution that is negative. So when you multiply a positive with the positive, you get a positive, right? When you multiply a positive with a negative, you get a negative. So you want a situation where the y value is positive and negative, which here, take a look, the y value is negative, and here the y value is positive. So if you multiply these two, you're going to get a negative solution, which is what we are looking for. But now we need to identify the value of x when that situation happens. So for us to really identify the value of x, we know very well that at this point, I'm just going to indicate with a different color. At this point, we are indicated with the yellow marker. At this point, x is equals to 0, right? Because it's the y-axis. X is equals to 0. So let me just indicate with coordinates. So it's 0 and whatever value of y, maybe it's 1, for example. But we know very well that x is equals to 0 at this point, right? So for us to interpret now or conclude our solution, since we are mostly interested in this side where y is equals to positive values, and here where y are negative values. So what you're going to do is just going to conclude and say, using this point here, so just going to say when x is less than 0, when x is less than 0, we are having a situation where the y values are positive for the inverse and the y values are negative for the y is equals to x line, and when they multiply together they give us a negative solution of y. Hence we are going to conclude with this answer of saying x should be less than 0. So that is the answer for this problem here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.